Welcome to the GCSE Maths Advantage. I'm Dr. James Carter, and every episode I'm going to break down one topic, show you where the marks are, and give you a quick win you can use in your next exam. Whether you're targeting a grade 7 or pushing for a 9. Let's get into it.
Hook. This one question lost more marks than any other on last year's higher paper. Simple quadratics turned messy by one tiny slip. Students watched 2 marks evaporate because they forgot a sign or because they dropped a coefficient. Sound familiar? If that feels unfair, stick with me. By the end of this episode, you'll have a routine that stops those marks leaking away.
Promise, plain and simple. Today we cover one concept, completing the square. One very common mistake that costs marks, and one practical 60-second routine you can use in any exam question involving quadratics. No jargon for now, just a promise. This will save you time and give you exact answers examiners like.
Concept. The why and the what. Start with a general quadratic, ax squared plus bx plus c. The idea of completing the square is to rewrite that expression as a times something squared plus a constant. In symbols, a times x plus h squared plus k. Why do we do that? 2 good reasons. 1, it gives the vertex of the parabola directly, so you can read the minimum or maximum immediately. 2, it gives exact answers for roots without relying on decimal approximations. Let's work through the algebra so it feels obvious rather than magic.
Step 1. Factor the leading coefficient a from the x squared and x terms. That keeps things tidy and prevents you from losing that coefficient partway through. For example, from 2x squared plus 8x plus 3, you pull out 2 from the x squared and x terms, giving 2 times open bracket x squared plus 4x, close bracket, plus 3. Important, we only factor from the first 2 terms, not the constant c.
Step 2. Inside the bracket, take half of the coefficient of x, that's the b over a value halved, and square it. In our example, the coefficient inside the bracket is 4, half of that is 2, and squared gives 4. You now add and subtract that square inside the bracket. Why add and subtract? Because adding and subtracting the same number preserves equality. We haven't changed the expression, we've just rewritten it in a clever way.
So, continuing the example. 2x squared plus 4x plus 4 minus 4 plus 3. Group the first 3 inside the bracket as a perfect square. X squared plus 4x plus 4 equals x plus 2 squared. That leaves the minus 4 inside the bracket. When you multiply back by 2, that minus 4 becomes minus 8. Then combine that with the plus 3 outside to get 2x plus 2 squared minus 5. That final form makes the structure visible and gives you exact information. Why this works. A quick explanation. Adding and subtracting the same number is a balancing act. Factoring a at first keeps the square term correctly scaled. If you forget to factor a, your added number will be the wrong size and you'll lose marks. When you complete the square, you're reorganizing the expression into vertex form, a times x plus h squared plus k. From that form, you can read the turning point as minus h, k, and he set the expression equal to 0, isolate the squared term to solve exactly.
Worked example. Let's treat this like a higher tier exam question. Solve 2x squared plus 8x plus 3 equals 0 by completing the square. First, factor the 2 from the first 2 terms. 2 multiplied by x squared plus 4x plus 3 equals 0. Next, half the 4 to get 2, square it to get 4, and add and subtract inside the bracket. 2 multiplied by x squared plus 4x plus 4 minus 4 plus 3 equals 0.
Rewrite the perfect square. 2 into x plus 2 squared minus 4 plus 3 equals 0. Multiply out the minus 4. 2 into x plus 2 squared minus 8 plus 3 equals 0. So 2 into x plus 2 squared minus 5 equals 0. Move the constant across.
2 into x plus 2 squared equals 5. Divide by 2, x plus 2 squared equals 5 over 2, which is 2.5. Take square roots. X plus 2 equals plus or minus root 5 over 2. If you prefer an exact surd, root 5 over 2 equals root 10 over 2. So the solutions are x equals minus 2 plus or minus root 10 over 2. That's a clean, exact answer the examiner will like.
Exam technique. Here's where the marks are. For this type of question, examiners usually award method marks for the key algebraic steps and an accuracy mark for the final exact answer. For example, M1 for factoring the leading coefficient and setting up the bracket. M1 for adding the correct squared term inside the bracket, remembering to add and subtract. M1 for correctly rearranging to isolate the squared term or for recognizing the perfect square. And A1 for the final exact answer. Even if you can't finish the algebra, write down the setup. That first M1 is often within reach.
Common exam mistakes to avoid. 1. Forgetting to factor out A from the first two terms. 2. Getting the sign wrong when you add and subtract. Students sometimes add the square but forget to subtract, or they move constants incorrectly. 3. Not giving the exact answer in surd form on higher tier when asked for an exact value. The partial credit strategy is simple. If you make a slip, show as much of the correct method as you can. Write it down, don't just think it. The examiner wants to see your method.
Quick win, your 60-second routine. I call it half, square, balance. Step 1, factor the a from the x squared and x terms. Step 2, half the x coefficient inside the bracket and square it. Step 3, add and subtract that square inside the bracket. Then simplify the constants carefully after multiplying back by a. Do this aloud in your head as you write. Factor, half, square, add, subtract, simplify. That short script keeps mistakes away.
The 10-second sign check. After you add and subtract the square inside the bracket, multiply the subtracting term by the factored a and check it against the constant you moved. If signs don't match what you expect, pause and rework that line. Most lost marks come from this step. The 10-second substitute back test. If you have time, plug one of your final values into the original equation. A quick substitute often catches careless arithmetic mistakes and saves marks. Don't skip the check.
Final recap and CTA. Completing the square changes ax squared plus bx plus c into a neat vertex form that gives exact answers and shows the turning point. A small routine prevents the two tiny mistakes that cost marks. That's your quick win for today. If this helped, share it with a friend who's revising. You'll find more work solutions in revision resources at jcacademyonline.co.uk. Until next time, trust the process and nail that exam. Stay curious.